Today we want to look and think deeply about the enum data type. And normally the enum data type is used to represent symbolic values. In fact, we don't really care about the underlying value for the most part. We'll have an enum called gender, and the symbolic names will be male and female. We'll have an enum called color, and we'll have names like blue and red and green and so on. And we don't really care that these are being represented by numbers underneath. We're just, say, reading in from a database and then comparing the enum value we got from the database to blue and say this record is a blue record. But in fact, there's two flavors of enum. You can have enum that's a conventional enum where there's only one value that's relevant, like a color is either blue or it's red, but it's not both. Or you can have a enum with a flags attribute that says we can have combinations of values. And there's actually yet a third flavor that I'm going to discuss in the next video. But for right now, we'll just look at the two that we see on the screen. The enum called person, where there can be only one, Connor, Duncan, or Raven. Or the enum called people, where you can have combinations as well. And you notice the values I have are 1, 2, and then 4. And the reason I don't have 3 as a possible value, because 3 in the case of the flags attribute is actually a combination of 1 and 2. 1 plus 2 is 3, so 3 is actually Connor and Duncan together. So if we look at the code I wrote to demonstrate this, basically we have a multi-line text box, and I'm doing append text to append information to it, sort of emulating a console write. And then I have a loop that goes from 0 to 7, which these are represented in bytes, so that's all the possible bit values you could have. And at one point I have a conventional use of enum, and that I cast the int value as an enum person, and then compare it to person.Duncan, which is how you usually use enum, and then we say we found Duncan McLeod if these match. And then in the second part I'm showing all the possible values of the byte, the 0 through 7, the bit values, and I'm showing what the symbolic values represented by them are. And we'll see it's pretty different for person, where there can be only one, and people, where you can have combinations. These turn out to be completely different. So if we run this, you see for all the possible combinations of enum without flags value, we have 1 is Connor, then we say we found Duncan McLeod, and 2 is Duncan, 3 is just a 3, 4 is Raven. But in all possible combinations of enum with the flags attribute, we have 1 is Connor, then we have the we found Duncan McLeod, 2 is Duncan, but 3 is Connor and Duncan combined. Then 4 is Raven, and 5 is Connor and Raven combined. 6 is Duncan and Raven combined. And finally 7 is the grand slam of Connor, Duncan, and Raven combined, because 1 plus 2 plus 4 is 7. Well, this is interesting, but some of the more thoughtful among you might say, wait a minute, if I have 8 bits, why can't I have 8 different people and then combinations of all of the 8 different people, like tons of permutations and combinations? And the fact is you can, but that's getting into a different concept of using an enum, which is the concept of it being a bit string or a bitmap. And that's the concept we're going to discuss in the next video. Well, I hope you enjoyed this video and learned a lot, and I'd appreciate it if you'd subscribe.